This is the lesson for Chapter 3, Section 3, titled Angles and Polygons. And so polygons are closed figure planes made up of three or more line segments that intersect at only one endpoint. And so that's what these are. You can see how we have a triangle here. We have this arrow. That would be a 1, 2, 3, 4, 5, 6, 7-sided figure. And here we have this kind of star here. That is a 1, 2, 3, 4, 5, 6, 7, 8-sided figure. So this is an octagon. And octagons typically think of a little bit different, but this is just a type of octagon. And we have things that are non-polygons. Again, they have to be line segments, and as you can see, these are curves. So what we can do with polygons is we can end up finding certain things like interior angles or exterior angles, and that's what we're going to do. Now, when we're dealing with polygons, we have two different types. We have convex ones, in which we can draw lines through and make triangles inside. And we have no side that is collapsed in on itself, like this concave one is. And so you can see how this is collapsed inside, and we can draw a line between vertices to make a triangle, and there's a part that's cut out. So with convex ones, we can find exterior angles. We can have rules for those to be able to find that easily. So typically we're going to be dealing with these convex polygons, but we do have one in which we have to find the sum of the interior angles. And it works this way. If you can take a line segment and draw it inside the polygon, and for instance this one here, and make triangles, you can find out how many angles there are, because we know from last section that the interior angles of a triangle make 180 degrees. So if we have two triangles inside, we would have 2 times 180. Again, the 2 comes from the number of triangles. And so when we go ahead and multiply those two numbers, that would give us 360 degrees, and that would be the answer we're looking for. Well, on this one, again, we do the same sort of thing. We just make triangles inside, and so you see how I can just kind of go around making these triangles, and I would have some triangles that way, and I can actually make some more as well. Now from inside, I can go ahead and cut it across this way. And so now we have 1, 2, 3, 4, 5, and then if I break it this way, 6, 7. So you can see how there's 7 triangles. 1, 2, 3, 4, 5, 6, 7 triangles inside. So 7 triangles that all have 180 degrees would give me 0, that's 56, and that'd be a 12 there. So 1,260 degrees. On this next one, we could do something similar. We could go ahead and I could break it this way, and then break it this way, and I'd have 1, 2, 3, 4, 5 different triangles inside here. And so 5 triangles multiplied by 180 would end up giving me 0, 0, and 4 and 5 make 9, so 900 degrees in this case. So there is another way to do that without having to make the triangles. We could end up looking at a pattern. So if I take this number of sides, there are 4 sides here, and I multiplied, I saw 2 triangles inside. Where on this one, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So there's 9 sides to this figure, and we multiplied by 7 because there are 7 triangles. Well, this one we have 1, 2, 3, 4, 5, 6, 7 sides. So with a 7-sided figure, we ended up getting 5 triangles inside. And so what we want to do is look for a pattern. What I see is every single time the number of sides is 2 less than the number of triangles. See, 4 minus 2 gives me 2. 9 minus 2 gives me 7. 7 minus 2 gives me 5. So if that's the case, we can come up with a formula. And so the formula goes this way. For the interior, or the sum of the interior angles of a polygon. And now notice it works with whether I have a concave polygon like this or a convex polygon. The sum of the angles of a polygon is n minus 2 times by 180, where n represents the number of sides. So the number of sides of the polygon. And we're going to use that formula to help us solve some problems because it just makes it go a little quicker. So all I have to do now, instead of drawing the triangles inside, is just count the number of sides and subtract 2. So let's take a look at some problems that we'll see. So here it says to find the value of x. And so what I want to do first is I need to figure out what are the degrees of this entire polygon here inside the interior angles. So I'm going to count the sides. 1, 2, 3, 4, 5, 6. So this is a 6-sided polygon called a hexagon. And so what I'm going to do is just do the formula, n minus 2 multiplied by 180. So I'm going to substitute 6 in there and subtract 2, and that's going to end up giving me 4. And so all I have to do is multiply 4 by 180, and that gives me the number of degrees inside the polygon. And so that makes 720. So now all I have to do is add up the sides. 135 plus 110 plus 125 plus 120 plus 125 plus x equals 720. So I'm going to use a calculator to help me with that math. So we'll go ahead and plug those numbers in. 135 plus 110 plus 125 plus 120 plus 125 plus, and then x. So actually I should press equals now. And that makes 1,230. So let's check that. Something went astray. So let me go ahead and add those numbers again. So 135, 110, and 125, 120, and we have 125 again. Press equals this time, and that looks like a much better number. 615 plus x equals 720. So I just subtract that 615 from both sides and do a little borrowing, and we'll get the answer. So 720 minus 615 gives me 105. And that is the value of x. So on this one, same sort of thing. So we have to first figure out what the degrees of all the angles are in this polygon. Well, this is a 5-sided figure, so it's just 5 minus 2 gives me 3, and I just do 3 times 180, and that gives me 540 degrees. So I'm just going to add up the angles. I have 2x plus 2x plus 145 plus 145 plus the 110, and that's going to equal 540. So when I go ahead and add some of those numbers together, I have 145 plus 145, and then plus the 110, and that gives me 400. So 4x plus 400. I got the 4x because I added the 2x and the 2x. And I'm going to now subtract that 400 from both sides, giving me 140. And so now I can go ahead and divide by 4. So 4 doesn't go into 14 evenly, but it does go 3 times with 2 left over, and it goes into 25 times. So 35 is what x is, and that's what they wanted there. So now we've got the exterior angles. So no matter what, on any exterior angles on any convex polygon, so the sum of exterior angles for any convex. Now it has to be a convex because with concave we have some angles that are much bigger than what we typically would have. So on exterior angles on a convex polygon, we never get anything bigger than 180. Actually, 180 we don't even get either. So we get numbers that are less than 180. And so the sum of the exterior angles for any convex polygon is equal to 360 every single time, 360 degrees. So all we have to do is just, when we're trying to find out what the missing measure here of this exterior angle is, we just add the angles. 50 plus 91 plus 127 plus x equals 360. So you're just summing up those angles. So we add 50 plus, let's see here, we have 91 plus 127, and that gives me 268. So 268 plus x equals 360, and then we just subtract from both sides. And so in this case it looks like 92. When I do that subtraction, minus 360 is going to give me 92. So that equals x. So find the measures of the exterior angles of each polygon. So these are the 4 measures along with 92 degrees. So on the next problem, same sort of thing. Doesn't matter that it is a triangle or a quadrilateral or a pentagon. You just add up the angles. And so in this case we have z plus 124 plus z plus 26 equals 360. So we end up with 2z plus, we add these numbers, we get 10, carry a 1, that's 5, 150 equals 360. So when we subtract that 150 from all sides, we end up with 2z equals 210. So you divide by 2, and that's where we're getting our answer of z equals, and it goes in there, 105 times. So 105 is what z is, but they wanted all of the angles. So we have 105 degrees for z there, and then we have to add 105 plus 26, and that's going to give us 131 degrees for this angle, and this angle is already given to us. So those are the problems that you'll see on tonight's homework. Good luck.